In Lecture 2 of our General Chemistry module, we're going to go into the periodic table, in particular, element families and periodic trends. The periodic table is an organization of elements by atomic numbers. It's divided into rows, which are horizontal, and columns, which are vertical. Rows are also called periods, and these are organized such that they all have the same principal quantum number when they're in the same row. Columns are sometimes called families, or groups. They have the same valence shell configuration. Therefore, they have very similar reactivity, hence why they're considered in families. The properties in general of these elements in families are going to be very common, much like your own family. If we are to look, periods or rows go straight across. So, for example, if I were to mark through, this would be a period. So, as I'm going, these are all listed as periods. We're not going to worry about the lanthanide and actinide series. These are by and large a little bit extraneous. If we were to discuss what families were, families are columns, so they go down. Like this, all across the periodic table. We're going to go into families in more detail later on. There are different types of elements, and when we talk about types of elements, there's three in particular. The first is metals. Metals are shiny and lustrous, and they conduct electricity. They're also noted to being ductile and malleable. These are in the left and middle of the periodic table. Nonmetals are on the right side of the periodic table. These are the exact opposite of metals. They're dull, poor conductors, brittle, and, like I said earlier, on the right. Where things get interesting is when we talk about metalloids. These have characteristics of both metals and nonmetals, and they stair-step down starting with boron. When we look at periodic properties of elements, there are a couple trends that we need to be aware of, and these are all based around effective nuclear charge. This is the electrostatic interaction between the valence shell electrons and the nucleus. It's a measure of the net positive charge experienced by the outermost electrons. There are a couple trends we'll talk about, and the arrows are noting increasing levels. So electron affinity and ionization energy increase from left to right and from bottom up. Atomic radius is the opposite, and as we go up towards the upper right, the characteristic of nonmetallics goes up, and bottom left increases the metallic character. These are some trends that you should be aware of for test day. As promised, let's go into the chemical families and their different reactivities. Starting first with cation trending families. If you remember, cations are going to have a preference to be positive. There are two that we will discuss primarily. However, transition metals often are cations as well, but we'll get into those a little bit later. The first one we'll go into are alkali metals. This is column 1. These generally have a +1 oxidative state, and they are the most reactive of the metals. Alkali earth metals are directly to the right of alkali metals. They have a +2 oxidative state and a higher Z effective than alkali metals. Elements in this family include beryllium and magnesium. Anion trending families tend to be nonmetals. They are chalcogens and halogens. Chalcogens are -2 or +6, depending on if they're metal or non-metal. They are important because they have a lot of biological functions. The all-star of this family is oxygen. Halogens have a -1 state, and they're highly electronegative. These are comprised of elements such as fluorine, chlorine, and bromine. Transition metals are intriguing because they take on multiple oxidation states and participate in a lot of complex reactions. For the purpose of the MCAT, we won't have to talk about these sorts of complex interactions, but just remember that transition metals all can possess very different oxidation states. So an example is if we look at iron. Iron could be everything from Fe+, Fe2+, to even Fe3+. In some extreme instances, you'll even see iron 4. So take note of this when you're going into the test. Iron iron and all the other transition metals are going to have varying oxidation states. The last family we're going to go into is the noble gas family. This family is interesting because they have a full valence, making them generally unreactive. Because of this, they have high ionization energies and nearly no electronegativity or electron affinity. If you remember, ionization energy is the energy it takes to remove an electron. Obviously, noble gases have a full valence, so they're going to be extremely loath to remove electrons from this full valence. Noble gases are important in particular because all the other families of elements are going to strive to achieve this full valence, or as it's commonly called, noble gas configurations. What you will note though is that xenon and the other heavier noble gases do exhibit reactions, but they're largely uncommon. So we finished our overview of the periodic table and its trends. If you're familiar with these trends, you're going to have a much easier time deciphering and discerning question types on the test. Please join us in the next lecture.